हॅलो स्टुडंट, आज आपण गिब्स एनर्जी हा पॉईंट पाहणार आहोत. मेन टॉपिक केमिकल थर्मोडायनेमिक्स या टॉपिकमधला गिब्स एनर्जी हा पॉईंट पाहणार आहोत. व्हॉट इन बाय गिब्स एनर्जी? गिब्स एनर्जी, द रिझल्टंट एनर्जी मेजर्ड बाय एन्थाल्पी अँड एन्ट्रॉपी of system at constant temperature is called as Gibbs energy or free energy. Resultant energy measured by enthalpy and entropy of system at constant temperature is called as Gibbs energy or free energy. Mathematically, Gibbs energy G is equal to H minus Ts, where G is Gibbs energy, H is enthalpy of system, S is entropy, and T is a temperature. As pointed out in the preceding section, it is necessary to determine a delta S entropy, change in entropy of system and surrounding, for predicting the spontaneity of a reaction. We are more interested in the system. It is therefore convenient to consider the criterion of spontaneity in terms of the thermodynamics properties of a system. This problem was solved by American theoretian J.W. Gibbs. He introduced a new thermodynamics properties called as Gibbs energy and usually denoted by G. Equation G is equal to H minus Ts, where H is enthalpy, S is entropy of system, since H, T and S are the state function. G is state function. A change in Gibbs energy depends on initial and final state of the system and not on the path connecting the two states. The change in Gibbs energy at constant temperature and constant pressure is given by change in energy. Gibbs energy or free energy is delta G is equal to delta H minus T delta S. यामध्ये गिब्स एनर्जी जी आहे ते गिब्स एनर्जी ही एन्ट्रॉपी आणि एन्थाल्पीवरती डिपेंड असते. एन्थाल्पी H मायनस TS आर टर्म ॲज गिब्स एनर्जी आणि चेंज इन गिब्स एनर्जी डेल्टा G इज इक्वल टू डेल्टा H मायनस T डेल्टा S. T delta S. Okay. Then Gibbs energy and spontaneity. The total entropy change that accompanies a process is given by delta S. Total entropy, change in entropy is equal to and change in entropy of system plus surrounding is equal to delta S plus delta change in enthalpy of surrounding. The subscripts system that refer to the system is dropped hereafter. Then relation between Gibbs energy and total entropy. Relation between Gibbs energy and total entropy. According to second law of thermodynamics, for a process to be spontaneous when change in total entropy is greater than 0 and if delta H is the enthalpy change accompanying a reaction, the enthalpy change of the surrounding is minus delta H with delta S surrounding is equal to minus delta H upon T. Substitute above in equation delta S total is equal to delta S minus delta H upon T. Thus, entropy, total entropy change in entropy is expressed in terms of the properties of the system only. Rearranging T delta S total is equal to delta H minus T delta S. Substituting in above equation, delta G is equal to minus T delta S total. T delta S total. For a spontaneous reaction, when entropy total is greater than 0 and hence change in Gibbs energy is less than 0 at constant temperature and pressure, Gibbs energy of the system decreases in a spontaneous process. The second law leads to the conditions of spontaneity which are summarized here. Delta S or total entropy, change in entropy is greater than 0. Change in entropy greater than 0 and change in Gibbs energy less than 0, the process is spontaneous. जर टोटल एंट्रॉपी ही ग्रेटर दॅन 0 असेल त्यावेळी गिब्स एनर्जी टोटल गिब्स चेंज इन गिब्स एनर्जी लेस दॅन 0 असते आणि प्रोसेस ही स्पॉन्टेनियस असते. याच्या उलट जर समजा टोटल चेंज इन एंट्रॉपी लेस दॅन 0 आणि गिब्स एनर्जी इज ग्रेटर दॅन 0 असेल तर प्रोसेस इज नॉन स्पॉन्टेनियस आणि दोन्ही इक्वल असेल. चेंज इन एंट्रॉपी टोटल एंट्रॉपी इज 0 अँड गिब्स एनर्जी इज 0, द प्रोसेस इज ॲट इक्विलिब्रियम. प्रोसेस इज ॲट इक्विलिब्रियम. ओके, देन spontaneity and change in enthalpy and entropy. From above equation, delta G, change in Gibbs energy, is equal to change in entropy minus T delta S at constant temperature and pressure. The temperature term determines relative contribution of delta H and delta S to delta G. Delta H, change in entropy and enthalpy, are both negative, then change in Gibbs energy will be negative only when change in entropy is more negative than T delta S. This is possible at low temperature only. जेव्हा एन्थाल्पी चेंज इन एन्थाल्पी एन्ट्रॉपी ही निगेटिव्ह असते त्यावेळी चेंज इन गिब्स एनर्जी सुद्धा निगेटिव्ह असते. चेंज इन एन्ट्रॉपी अँड एन्ट्रॉपी बोथ आर पॉझिटिव्ह ॲट दॅट टाइम. डेल्टा जी विल बी निगेटिव्ह ओनली इफ टी डेल्टा एस इज ग्रेटर दॅन टी डेल्टा एच. दिस इज अ पॉसिबल ओनली ॲट हाय टेम्परेचर. ओके, देन for delta H negative and delta S is positive, the following follows that a delta G is negative regardless of temperature. For delta H positive and delta S is negative, then delta G is positive regardless of temperature. Such reactions are non-spontaneous at all temperature. Okay, then temperature of equilibrium. Delta G is equal to delta H minus T delta S gives T is equal to delta H upon delta S. T is temperature at which the change over from spontaneous to non-spontaneous behavior occurs. Delta H and delta S are assumed to be independent of temperature. Introducing of temperature depends of delta S and H would not cause significant error for the moderate temperature range. Okay, then Gibbs function and equilibrium constant. Gibbs function and equilibrium constant. Gibbs energy change for a chemical reaction is given by delta G is equal to delta G0 plus RT ln Q, where delta G is standard Gibbs energy change, that is the Gibbs energy change when the reactant and products in a reaction are in their standard state. Q is called as a reaction content, is analogous to that of the equilibrium constant, and involves non-equilibrium concentrations or partial pressure in case of gaseous reaction. Okay, Gibbs function and equilibrium constant यामध्ये चेंज इन गिब्स एनर्जी जी आहे जी इज इक्वल टू डेल्टा G0. G0 म्हणजे स्टँडर्ड गिब्स एनर्जी आणि आर गॅस कॉन्स्टंट टी ln Q याला आपण क्वांटिंट असं म्हणतो. ओके, फॉर एक्झाम्पल consider A plus B reaction to give C plus D. Delta G is equal to delta G0 plus RT ln Q quantity. Delta G0 plus RT ln concentration of product divided by reactant, or delta G is equal to delta G0 plus RT ln QP. Delta G0 is equal to RT ln concentration PC into PD upon PF into PB. Then when the reaction reaches equilibrium, standard Gibbs energy is equal to 0 and QC and QP becomes KC and KP respectively. 0 is equal to delta 0 plus RT ln Kc and 0 is equal to delta G0 plus RT ln Kp, or delta G0 is equal to minus RT ln Kc and delta G0 is equal to minus RT ln Kp, or delta G0 is equal to minus 2.303 RT log to the base 10 into Kc, and delta G0 is equal to minus 2.303 RT log to the base 10 Kp. ओके, यामध्ये एल एन हे कॅन्सल करण्यासाठी त्या ठिकाणी मायनस 2.303 लॉग टू दी बेस 10 येतं. जेव्हा एल एन हे यातून कॅन्सल होतं त्यावेळी 2.303 आणि लॉग टू दी बेस 10 येत असते, आणि ह्याचं कन्व्हर्जन, ह्या इक्वेशनचं कन्व्हर्जन डेल्टा G0 इज इक्वल टू मायनस 2.303 RT लॉग टू दी बेस 10 KC अशा प्रकारचे होते, आणि KCच्या ऐवजी आपण या ठिकाणी KP घेतलेलं आहे. दिस इज नथिंग बट दी गिब्स एनर्जी. ओके, देन